block, tell him to like exchange with me directly, but that's really weird because we had a lot of people that enter the room and everything's open.
I think ask Jordi to join through Vuva if he can.
Yeah, but he has to
problem
present. He has to present.
But
he's just one of the speakers.
Yeah, you can do the present. It's not that you can also share your screen with Vuva. So it's
okay.
It's just more convenient to do it with the.
He's Jordi. I think he's. There is a participant named Jordi.
Yeah, Jordi's here.
With,
yeah.
Okay, Jordi's back. Yeah.
No,
Yes.
I'm back through Vuva, not via Zoom link. So for whatever reason, that Zoom link for me is not working anymore. I don't know what's happened. So I was able to connect, and then it says continuously that kind of if I was forbidden to join again for whatever reason. I don't know what happened.
Well, I'm Alessandro. I am with the WOWA 2. I can't join with the Zoom link, but well, I'm with WOWA. It's okay for me.
Okay, as long as Jordi, you can do the presentation via WOWA, I think it's okay.
Well, let me.
Okay, guys.
Let's
try. Start because it's 7.
Yeah.
And yes, let's start.
Yeah, but just try, Jordi, could you please share the screen? Just a second.
Yeah, that's what I was wanted to do. Just okay, I cannot share the screen.
Sorry, because I'm sharing. Yeah, sorry.
Okay.
Yeah.
Should we stop?
Let me try.
Yes.
Again.
Yes, perfect.
Okay. So you.
Yeah. Okay.
Good. So we do it like this. I mean, not the best start, but it is.
Yeah.
Like this. Okay.
Okay, thanks. So yeah, if you can stop sharing, and we can start the workshop with the presentation, the introduction. Share my screen. Yes. Okay. Hello, everyone. Welcome to this first edition of the workshop on modeling and low-code development platforms. So it's the first edition of the low-code workshop at Models. And I'm Davide Di Ruscio from the University of L'Aquila. And together with the co-organizers of this workshop, we really looking forward to have very interesting discussions in this during this event, and that of course it will be about low code, right? So you know that many low code development platforms are getting very popular from different news and sources of information, and you know that many low code development vendors are also coming out, and you see this is just. There is one report that mentioned that more than 144 local development tools are available out there. So it's, it's an interesting domain to look at to see what is going on. And so what's but I mean, we are okay, low code, but what mean with low code? There are some definitions from industry. The first definition from appeared in 2014 is a new development platforms emerge for customer-facing applications. So essentially, this definition is paying more attention on citizen developers, let's say, people that do not have a strong expertise in IoT, but still want to develop some applications and some software systems. In Gartner in 2019 also defined a low-code development platform as a platform that supports the rapid application development in one-step deployment, execution management using declarative high-level programming abstractions, such as, of course, model-driven and metadata-based programming languages. So some concepts and notions that are very, are popular for us in the model-driven engineering domain and field. So what's the objectives of this workshop? of course, we want to bring together both developers, but also users of low-code platforms together and talk and discuss about what are the current challenges, what are the open challenges around this domain, what are the challenges that both vendors and users of low-code development platforms are facing today, or even explore some additional technologies that can make even better now these low-code platforms, and also identify solutions that can be, solutions provided and developed by model-driven engineering community that can be used and bring it pulled in the context of low-code development. So in terms of topics of interest, this is not a complete list, but the idea is we want to understand what are the technologies that underpin low-code, also understand what's the link and between low-code and MD, and I think that one of the talk will be about positioning the low-code movement with the field of MDE. What's the role of citizen and users of the development? You see that we'll talk about a lot of topics of interest. So, as I said, this is the first edition of this workshop, and despite that, we got good numbers of submissions. We got 21 submissions. Most of them were of high quality. In fact, we decided to accept 17 papers. According to the numbers and to the analysis that has been done, it seems that this is the highest number of expected participants across all the workshops at the year models. In terms of submissions, it seems that the most authors come from Italy, then there is also UK, Spain, Portugal, France, and then we have Austria, Netherlands, Hungary, and also Iran. So what's the agenda? So we have, different sessions. It is going to be a long day, but I think that I think that there are the possibility to, I think that we'll join the whole program. We start from our keynote that is going to talk about the future of low-code. Then we'll have a session on MD and low-code platforms, to try to bring and to draw the lines between these two topics. Then we have a session about testing of low-code applications. Then we have a model management in low-code platforms. Then we have a session about DevOps and low-code development. And then we also another session about recommender systems and machine learning still in the domain of low-code platforms. And then in the program, we also have, we planned to have a session to discuss. So the idea is that all the participants that are willing to do so can write some challenges or topics that they want to discuss during this discussion session. Even though also the organizer will try to identify some interesting topics that might be useful to discuss in the last session. Of course, you are free to discuss and post topics in the chat. And we will keep an eye on the charts and also for forwarding questions to the speakers. So after the workshop, of course, the ACM proceedings are expected to be available in the forthcoming days, and they're also exploring the possibility to have a special issue on a journal. This is under discussion with the organizers, but most probably we also have a special issue on this topic. So that's all. So enjoy the program. Shut up. I would introduce our keynote speaker that I said will allow us to do a jump in the future of low-code. And our speaker is Johanna de Haan. You know that he's a CTO of Mendix. Mendix is one of the low-code platforms that I think that all of us knows. And Johan is interested in many things. I think that his background is on MD, model-driven development, also domain-specific languages. So topics that are quite. We are used to to listen to in the MD community, and I think that Mendix has been recently acquired from Siemens, and maybe Johan can say if this is true or wrong. I think that this acquisition has been done in 2018, but I mean, I would like to
2018.
Yeah. I would like to them to pass the voice to our keynote speaker, and thanks for accepting for joining us today.
Thank you, David, for the kind introduction. Let me share my screen. There we go. So welcome everyone. It's great to be here at the first scientific workshop on low code. Although many might ask, what's the difference, right, with the previous workshops on closely related topics? But let's not go there yet. And let's first look at what low code is. The term low code has been introduced in 2014 by John Reimer, a Forrester analyst. And the goal of the term low code was twofold, basically. One, it was to a message that you can build software rapidly using visual models, so instead of code. But he also meant to say it's low code, not no code, because you still need a bit of code to finish the last details. Hence, he called it low code versus no code, and he actually recently wrote a blog post about that again to kind of explain that. But when he introduced this term, the term was kind of sticky, and everybody started to use it. So let's, even Gartner actually. So as an analyst company, they don't like to copy each other's terms normally. They normally come up with their own terms to further confuse the world. But in this case, it was so sticky that everybody just kept saying low code, while Gartner was talking about high productivity application platform as a service in the beginning. They define low code as, and this is the most recent report of a month ago, they define it as low code application platforms, and they specifically point at model-driven or visual development paradigms. And then of course you have some additional expression languages to finish your model. And then focus on use cases, yes, also citizen development, but also enterprise application development for more complex applications. And they predict that by 2023, so that's 3 years from now, that over 50% of medium to large enterprise will have adopted a low-code application platform as one of their strategic application platforms. So that's not just, I mean, I think we might even be at 50% already of the companies using a form of low-code somewhere in their company. But in this case, they talk about people really adopting it as a strategic platform to do their core software development. So you see a bit of the players at the right. So I think Gartner has the most read analysis on low code. So it's an important quadrant for us as well to be in. So you see Mendix is positioned as a leader. So I'm really happy to be there again. And for the 4th time in a row, we are positioned most to the right as for completeness of vision. So happy to be there. And of course, we do our best to stay there. And that's also one of the things I want to, what my goal is for today is to make sure that I share how we are looking at the future of low code, but also to invite you to take part in the research and help us push the boundaries of what low code is and what it can be in the future. So low code and model driven are both used on this slide. So which reminds me of this cartoon. And I used this cartoon in 2009 when I found it. I don't even know where I got it from. I tried to find the source, but this is the decades-old dream, basically. Like, hey, if we are programming, it's like building a house manually, and then we can do modeling and generating. So we just model a tiny house, and then we put it in a machine, and we get the full house. And then this is the metaphor for software. What is funny though is that in my mind, if I look back 11 years to 2009, it almost feels that the metaphor itself has come further and more complete in this vision than the actual software. Because if you look at houses, you can now 3D print a house. So you can actually build a model of a house and print it. And then you have something like this. So it's an experiment, but it's going quite well already. So we could ask ourselves, have we used that cartoon in the past? Maybe we should have been a bit faster, because if the topic of the metaphor actually is faster than we are in software, then something is off. But let's revisit that in later on. So what I want to talk about in the next 25 minutes is 3 things. First, a not so scientific view on the history of low code, a view on what's next for low code, and I want to end with the science low code needs. Basically my view on what a research agenda for low code could mean, and what at least would help me in with Mendix to take the next steps. So when you think about the history of low code, I thought, well, I can try to do a very comprehensive view on the landscape and so on, but I think there are people in the audience that are much better suited to do that. So what I tried to do was just looking back, and it was actually funny to do that while preparing this presentation, to look back at my own presentations and blog posts over the last 15 years almost. And in that kind of review, how my view on model-driven development, DSLs, and then basically from executable UML to the low-code platforms of today, how that view has evolved. Not to make it all about me, but this is, I think, a useful way of showing how we have been thinking as a vendor about low-code and how we evolved, instead of and just to add that as a perspective to what you already have in mind when you look at the science of model-driven engineering in general. And it also gives a bit more context to what low-code is versus trying to define it on one slide. So really look at how it evolved over the years. So my first, actually, the first thing I thought about when I was invited to do this presentation was that actually my first scientific conference was Models as well. Models 2008 in Toulouse. Was a fun time. We were a sponsor as a company, so we were a vendor, and we thought, well, we have to sponsor conferences to get more attention. So we ended up at a scientific conference. We didn't do that again because it didn't deliver us a lot of customers. But it was fun to be there and have discussions and fuel the discussions on model-driven engineering in general. And my first kind of memory of this conference was a panel on a panel discussion on the past and future of model-driven development. So I just have 5 quotes from the top 5 quotes from the panel. That's how I wrote them down in my blog post in 2008. UML is the worst modeling language except for all the others. The difference between terrorists and modeling experts, you can negotiate with terrorists. So this is what I learned about scientific conferences. They are quite funny. Java is not a bad Lisp if it were not for the lack of parentheses. UML is both a blessing and a curse, and then a UML tool has a far more complex interface than a modern aircraft cockpit. So this was kind of what triggered me to keep going with what we were building at that moment, to build a less complex interface for a less worse modeling language to actually build software. And by the way, the panel discussion also ended with a long discussion on graphical versus textual languages. I've been part of those as well, and happy participants in these discussions. But that's, I think, how the world was looking at that point in time. The discussion was all around UML and modeling languages, and executable UML was becoming a thing, of course. And what I started to do in that time was actually trying to sell MDD, because we had this first tool to build applications, web applications using model-driven development. We also positioned ourselves as Mendix as a company as a model-driven development tool. And I tried to sell that. I was looking back at those blog titles. It's a bit of clickbait, I have to admit. So some things to kind of trigger the discussion and to get attention on the topic of MDD. But what we were actually trying to build in that period was this. So basically a model-driven development tool to build web-based applications. And our focus was on horizontal DSL, so domain-specific languages, to describe different parts of the application. And then we integrated them in one modeling environment. So you could define your data model, use that in your what we call the rich forms DSL. We had a microflow DSL to describe logic, mapping for integrating with other systems, security, of course. So those were the basic languages we used. We didn't replace CSS, as that's a DSL already, I think, for designing your interface. And then we mapped that on our runtime engine, basically. So we are an interpreted language, Mendix, so we don't generate code, although there's some generation going on as well, of course. So that's it's a gray area. So and then our engine looked like this. So really an object relational mapper with some access rules on top, and then you have your flows and actions defined in your microflow DSL. You have APIs and connectors with mappings to get data in, and then you will present that in a web-based application. If you then fast forward a year, then Jordi, who's also presenting here, actually interviewed me for the Modeling Languages website. We were both very active in that period with blogging and tweeting and basically evangelizing model-driven engineering. But it was funny to look back at this quote, because what I predicted then was that there would be a growing adoption, which was, of course, maybe the hope I had instead of really having a crystal ball. Adoption of MDD, but people won't call it MDD. And my thinking there was resolving around, okay, it's not just about development, but more about additional trends in software development. So cloud, so really we saw a raising level of abstraction in cloud infrastructure, MDD itself, and then also App Store, so to have out-of-the-box building blocks you can use and speed up your development much more. And I kind of refined that idea the year after, when I did a presentation in Nantes. And what I learned there is, what I shared there was lessons learned during the building Mendix, basically a model-driven software factory, if you will. And the things we learned during the 5 years we were doing Mendix at that time, or almost 6, because we started in 2005, is that development, if you build software, development isn't the difficult part. The challenge is to translate a business problem into a solution. So how do you focus on that? How do you make sure that people can focus on building that model? It's also not, development is not the slowest part of developing software. We learned that deploying that software and taking it in production actually is as cumbersome, or maybe even slower in some areas, especially if you are already doing MDD. Then basically the next bottleneck becomes deploying and taking software in production in enterprises, because that involves a lot of additional steps that you have to take. Being able to change software is more important than building it in a fast way. So you can build it fast, but if you cannot evolve, then you have a problem. And from an economic perspective, MDD was not that important for our customers. So they were looking at broader issues and where they were losing money, basically. So that led to the conclusion that MDD is a technology enabler. It doesn't have business value on its own. So it's necessary, but it's not sufficient. And we started to think more in a broader life cycle of applications. And in addition to just modeling applications in step 2, we actually added a separate tool on top. We called it Sprinter at the time, to do your project management, basically your Scrum process. And then also started to introduce all kinds of tools to deploy your application automatically in the cloud and then gather feedback. So really having that complete cycle there. So with these lessons, I stated like, well, there is no future for MDD. I admit again that it was also to trigger people, as I was invited to talk about MDD to a lot of MDD enthusiasts. But my focus was shifting to the broader app lifecycle. And you could basically say model-driven engineering versus model-driven development. And at that same time, we saw that, I'm talking 2012 then, we saw that the app economy was coming up. So we saw statistics like there are now almost 500,000 jobs in the US in the app economy, while there were 0 in 2007. So what changed was the introduction of the iPhone. So, and that actually learned us a lot. And we could learn a lot from that to what it means to be a successful platform for developers. How do you attract developers to use your platform to build software? How do you make sure that they keep doing that and basically build that economy around your platform? And then along with that, the market itself also helped us. So we saw an increasing need for speed. So I just picked Uber as an example, but I use many examples in that area. You can Airbnb, all these companies that kind of were disrupting industries because of how they put software central to their business process. And if you think about it, then you need to do basically two things. You need to improve the entire application lifecycle. So that's what I said on the previous slide. But you also need to make sure that you have the right building blocks in your platform. So we started to think much more as a platform versus a tool. So instead of having an MDD tool, we were positioning ourselves as a platform. We integrated those separate tools into one platform. And we started to think about this whole stack from the software-defined data center to a platform as a service in multiple layers. And we actually started to talk a lot about model-driven platform as a service, which brought basically new opportunities to bring model-driven development to a broader and new audience. I started to use this term a lot to explain how a combination of visual languages on top of cloud abstractions could help the market to find speed and agility, the speed and agility they really needed. So you get to this full stack. It also basically brings new opportunities to add additional DSLs, not just on defining your application, but also on defining the integrations or the reports and analytics or the lower level layers of the cloud stack. So I see it as a huge opportunity, and I still see it that way, and I will talk about it a bit more later on, because I think we still have a lot that we can do in this area to research and to add new languages. But we really started to think about this cloud world, and it actually helped us to basically start to position our platform on top of Cloud Foundry and underlying infrastructure. So Forrester at that time presented an overview like this. You have the DevOps people, so really focusing on the cloud infrastructure layer, the coders on platform as a service. So Heroku, we had Bluemix from IBM, Azure PaaS from Microsoft. And then Rapid Devs, they started to talk about it again, because they introduced low code in 2014, as I said before. So they started to look at the big vendors like, hey, are they also thinking already in this direction in low code? And they saw some things happening. Force.com with Lightning, that still exists. AWS didn't have anything yet. IBM tried something with RapidX, but they killed that. And then Microsoft also had something with MapMatrix, and nowadays they have Power Apps, of course. So we started to position ourselves as basically to help IBM. HP at that point in time also had a platform as a service, Pivotal, SAP, all the players that were focused on Cloud Foundry as the open source platform as a service, and said, well, what you guys need to compete with Salesforce is also something for the Rapid developers out there. So you need Mendix on top of your Cloud Foundry stack, and that actually led to these partnerships with HP, IBM, Pivotal, and SAP to actually drive those partnerships with a low-code offering in this entire stack. That brings me to the last part before starting to fast forward to the future. Is, I think, the last phase in our thinking around low-code, and just to explain how we currently look at low-code, and I think how the market looks at low-code, is that it's not just about the platform itself and how you build software. It's also about the type of software you can build using the platform. So we started to talk about and introduced in 2016 at Mendix World, our conference, the term smart apps, where we say, okay, these are apps that are intelligent, proactive, and context aware. So they really use AI, machine learning, maybe data from IoT to make applications more proactive, to really guide the user. And that's the type of applications you need to build. And if you want to build that, you need an entire stack with many different technologies. And I'm not going to explain every cell. I think that goes a bit far now. But and the only way to master that, if people talk to me like I'm a full stack developer, I always think about this kind of matrix in my head, like, okay, then you're smarter than me, because you cover a lot of technologies if you are really a full stack developer for building smart apps. So I think the only way to really help people do that in a managed way is to actually provide them that model-driven platform, and to give them that platform to do it at a higher abstraction level and bring all these technologies together and build smart apps quickly. But with these additional areas, you of course need new DSLs. So with the expansion in cloud layers that we talked about before, and the additional DSLs to build smart apps, we get to what nowadays is called enterprise low-code platforms. It's not just defining the application itself, it's how you deploy them, how you manage and operate them, the integrations, other elements that you need to build these type of applications. That's when, if you look at, for example, the questionnaire that Gartner sends out to vendors, to all the things you need to answer, and then based on that, they and the presentation you do, they evaluate you and put you in somewhere in the Magic Quadrant space. There's a lot of additional things, and basically no question about how you do your actual modeling languages and what kind of technologies you use behind that. It's all about the type of things you can build, the type of architecture, the scalability, the security, all these additional things that you need for enterprise application platforms in general. So let's switch gears here and start looking at the future. This is what I said, a brief view on how my own views evolved over the years. So what's next? We started here. So what I said is, this is what we were focusing on in the beginning days of our journey. I think the value that we provided was in providing small, easy to learn languages. So small DSLs for specific aspects of developing software, but then integrated into one modeling environment. So if you had change propagation, if you change something in your data model, it propagates to the UI, and then so you don't have to update that manually. So everything is kept consistent. You have consistency and validation all integrated. And that gives you that productivity that you need to build software quicker. But we have to take that to the next level. As I briefly pointed at when talking about smart apps already, the world is changing and more technologies are coming. And actually, if you look at the challenge we have nowadays, is that I think we mastered software development, so application development. So that's covered with our low-code platform. But then our customers start to bump into new challenges, because then if this is fixed, then you get into new bottlenecks in actually automating or digitizing your business. So we need to move from, and for now we call it all-in-one low-code. So from just low-code application development to all-in-one low-code. So we should low-code all the things. So abstraction and automation have made development a lot faster, also of higher quality, I think, and also accessible to a much broader audience. And now we are taking that approach to other fields like data integration, intelligent automation. So workflow, BPM is basically all integrated into this platform space. So what we will see in the next years is a lot of these areas around or in enterprise software basically merge into one platform definition. So we now talk about integration platforms, application development platforms, workflow BPM platforms, AI platforms, multi-experience platforms. I think that this will all merge into one definition of a platform to automate your business. And for now, the term is all-in-one low-code. We'll see if we can come up with a better term for that. So basically what's happening is moving out of application development and targeting all these other areas with a low-code way of doing things. So defining modeling languages, abstractions at the right level. And the right level, I mean, it's easy enough to use, but you also have enough flexibility to actually do your job. And then the question, of course, is how do we keep that value of and productivity in the platform? And for that, I think we need to move from a modeling tool to a modeling platform. So we need multiple DSLs to cover all aspects of digitizing an enterprise. So not what I said, not just application development or the tools in there, but also for data integration, for workflow, all these adjacent areas. But then in a way, I mean, there is already a visual language to define workflows in many tools, but make sure that it is integrated. So we have these multiple IDEs, and we have tailored IDEs for specific personas. So you can say a citizen developer has a different view on one of these models than a more professional developer. But they should be in a central model repository that ensures consistency, because then we can provide the same thing that I just said about the different DSLs in one tool. I think we now move one step bigger. We have multiple tools, multiple IDEs connected to the same model repository. But then we have change propagation across all these models. So whether you're working on IoT, on AI, on data integration, on your workflows, on your application itself, it's all connected and integrated to keep that productivity. But it asks a lot of different requirements from that modeling platform. And that's something to think about when we look at research as well, in my mind. So just to give you an example, to share that the importance of that. So we're, of course, now, as David also mentioned in the beginning, we're now part of Siemens, which also has focused a lot on IoT. For example. So they have a lot of customers that are machine builders or that are factories, car factories or whatever product they are building. And just imagine all these machines in those factories, they become connected to the internet, so Internet of Things. So they produce a lot of data. So just imagine if you are this developer here and you need to build an application on top of all that data. So that machine needs to be connected to the cloud in some way. So you have an asset model. You get a lot of data, sensor data, streaming data from that machine. You need to produce that in your IoT platform. It's all time series data. You need analytics on top of that. So you want to analyze that data. You probably need data pipelines to do some data cleaning, combine it with data from your enterprise, so the big data store here. You probably want to produce, based on these analytics, you want to produce business events. So if something interesting happens, an anomaly or whatever you can do with combining all that data. And you want to build applications on top of that users can access. So dashboards, workflows, application logic. So it's a lot of different parts that need to be defined. And just imagine what happens if the vendor of this machine does a software update to give you some awesome new capabilities with an additional data field, or maybe the type of one of those data fields changes. Just imagine how many changes you have to do in the whole chain of tools, all the different tools you used, all the different models you created. That's a nightmare. It's error prone, it's slow, it's really hard to do that. And that's why a lot of these factories are actually running on old software. It's really hard if you are having this all in place to keep evolving that. And that's why we need to bring all those models, all those different tools together on the same modeling platform, so you can actually see the impact of those changes, to propagate them maybe automatically to some of these other tools, and to trigger, whether that's with a manual step in between or not, but to trigger new deployments to actually produce that updated data format. So if you have all that integrated tooling, that all in one low code, that would be an enormous productivity boost. It will reduce errors and bugs, and it makes it a lot easier. So also available to a broader audience to actually build those type of solutions. So that is, in my mind, one pillar of the future of low code, is that all-in-one low code approach. The second pillar in my mind is AI. So I think the future of software development is what we could call AI-assisted development. And I think low code is actually or model-driven development or engineering in general is actually well positioned to reap the benefits of machine learning and AI to help guide the user build those models, because it's already on the meta level, so it's easier to reason about these models and easier to provide guidance that's actually helpful to users. And if you think about AI, I'm thinking about 4 maturity phases for AI-assisted development. And I play a bit with the AI letters. So I think it starts with assistive intelligence. So really saying to a user, if they say, okay, what is, if you build a process flow, what is the possible next step to add? That is a suggestion you can do. So that's really assisting the user. I think the next step could be augmented intelligence. So really augmenting what the user is doing. So if you see that the user is adding, maybe with assistive intelligence, a number of steps in a process, then you can start reasoning about, okay, I now understand the intent of that process and I can immediately complete it for you with multiple steps. It's more proactive. So the assistive intelligence is reactive. It can guide you if you want. Augmented becomes more proactive and really helps you build your software. And then we can get into autonomous intelligence. Maybe we can produce bots that look at your model. If you do a commit, it starts to analyze that. And maybe if you don't comply to your own best practices in your application model, this bot will automatically fix that for you and do a commit as well. So you're actually almost collaborating with that AI. And that brings me to the 4th phase, where we really see, you could call that anthropomorphic intelligence. So really like virtual team members that help you build software. So that's a bit far-fetched maybe, but it would be great, right? If you're now lonely behind your laptop building your first software application, then you already have a virtual team helping you actually do that. And it's not just about development. It's about all aspects of the life cycle of an application. We should look broader than just development. And just imagine assistive intelligence in the design phase of your application. It could be that you do feedback management. So you get all kinds of feedback on your application. If you introduce a feedback button in your app and you have a lot of end users, you get a lot of it. So what if assistive intelligence could be, if you are processing that feedback, that it assists you in providing the right tags to add to feedback, to categorize it, for example. But all the way to anthropomorphic intelligence, where you would have a virtual team member actually processing that feedback for you. So deduplicating it, tagging it, categorizing it, accepting it, or rejecting it to a certain level. And we can, of course, there will be needs to evolve in steps. Or in operations, assistive intelligence in operations could be that if you're looking at the graphs, the monitoring of your production application, that it flags anomalies for you. So you're pointed at the right places to look at. All the way to anthropomorphic intelligence, where we talk about a virtual team member that actually warns you proactively before something happens in production, and maybe even writes a post-mortem for you to show you what happened and if they did a corrective action. But to be fair, I think the current state is that we're only focusing here. So just at this one point, assistive intelligence in the development phase of applications. But I just want to show, like, if you think about the future, there's so much more we can and should do. There's also a lot of research we have to do to actually be able to get to that. So what we are currently have already, and that's the first phases, just to share, is basically what we call Mendix Assist. It's a family of bots. So we have a pair programmer bot and a performance bot, and I will briefly show you both of them. So the first one is the pair programmer bot. So that's what I said, assistive intelligence. It helps you build these flows. So it suggests you a top 5 next steps, and those next steps out of the list of between 50 and 100 activities, you only have 5 to choose from. So it's a productivity boost, and it's already more than 95% accurate in that top 5, which is not bad. And we see that if you look at the success in practice, so it's in production, so users of our studio are actually using this, and 40% of all microflow activities are already created using this assistive intelligence. So not, again, manually dragging and dropping that from the right side of the screen. So it's not just research, it's already being used and successfully in production. So the other one, I don't have a movie of this, but it's just a screenshot to show you what's happening, is the performance bot, which actually shows you suggestions on improving the performance of your model based on best practices. So it will automatically say like, hey, we see an issue in your project, you can make this faster. And we can also automatically fix that for you, actually. So in this case, you see a loop here. There is a change activity in the loop. You can move that out. So just do the commit in that activity, have a separate commit activity to actually store the data in the database. So first do all the changes in your loop and then store the whole list. So that's a very simple example, but these are the type of mistakes that inexperienced people make. And it's great that we can automatically suggest that. And if you then combine this AI with the all-in-one low code that I talked about before, then you can think about, hey, this smart apps, building smart apps, we can think about, hey, we can use AI to suggest workflow steps or security rules based on patterns in your IoT data. And the available cognitive services to do image recognition or processing or whatsoever. So really start looking at that whole field. And then, of course, combining it all brings new opportunities for AI to help. Live learning, so learn from the behavior of users and then feed that back into the design time environment, or using AI to suggest what data to use based on learning from previous apps. So maybe you're building an application and then AI starts to suggest like, hey, you're building this, you're adding this entity with attributes. It looks a lot like something in that other application. Don't you want to build an integration instead of just defining the data again and basically duplicating all kinds of data models across your landscape? So just some pointers to think about. And that brings me to the last phase, is the science that low code needs. And that's very personal. So I'm just trying to explain, if I think about what I could use from the scientific community, and this is also an invite if you are interested to reach out to collaborate, are these things. So of course, the first thing when you think about is, it doesn't help to have something that we are already working on or need next month, because that's something we are engineering. We have development teams on that. We need to skate to where the puck is going to be, to say that with Wayne Gretzky. That's what we need to do the research on, so that when we are there, we actually have the right research ready. And that's easier said than done, because we probably feel more like this. It's not that we just skate to where the puck is going to be in an easy way, but we can take steps to get there. And that's what I would like to explore. So I already talked about all-in-one low code as a future for low code platforms, also about AI assisted development. But I have two more topics I would like to highlight as potential areas that we can use. So the first one is language extensions. So just to say, it's a bit of a broad idea, but to annotate APIs and data with proper metadata so that they become an integral part of the app model. So you basically extend your programming language by the additional data you get or data integrations you get access to. So you get more and more built-in knowledge. And a great example of that is the Wolfram language. I don't know if people know that, but it would definitely, I would expect so if you are in the language engineering business or science. But it's a great language to use as an example here, as it really a lot of built-in knowledge that you can use, and then have basically all kinds of operations in your language that do something with that knowledge. A simple thing is to reason about dates or the weather or countries or things like that. So things that are not out of the box in an average programming language. We are exploring that a little bit with the Mendix, what we call the Mendix Connector Kit. So you can build a connector for any system out there. And Connector Kit then basically adds a thin layer of modeling concepts on top of that, so that if you import that connector in your model, you actually don't just have an integration with another system, but you actually get a whole data model with that and some operations for your language that you can then later on use to manipulate data, to work with data, and so on. That's basically extending our Microflow language when you import these kind of things, and they all really appear as activity types in the Microflow language. Our new data hub that we introduced early this year also follows this principle. You can just drag and drop data and then operate that like it's part of your core language. The second idea here is to do a lot more with operation. So derive all deployment meta information and non-functional characteristics from the model, and then automatically generate the right configuration for your lower layer. So just some ideas here. You can specify an SLA for an application and then measure compliance at runtime, and then adjust the infrastructure if needed. All metadata driven. So I would say people in the cloud world are talking about software-defined infrastructure, software-defined data storage, software-defined networking. I would say we need to move from software-defined to metadata-driven. So we can really adjust things like the elasticity of resources, deploy on a location closer to the user with low latency. This is possible with today's cloud infrastructures if we actually use that. Or if an application based on, in the model you see integration points with other apps, then you can automatically configure the network to actually allow that, but then also shield for other access, or configure the integration platform, or auto provisioning the right database. You can imagine that based on the characteristics of the data you use in your application and how you use it, you can determine like, oh, do I need a NoSQL database or a SQL database, or maybe even more of a big data store for my analytics. These are things we could derive from the model if we do it in the right way. And that brings me to the last part, pointers for a research agenda. And I will share the slides because it's a bit a lot to go through in the last 10 minutes. And we also want to have some time for Q&A. But if you have those 4 topics, AI-assisted development, modeling platform, the language extensions, and metadata-driven operations, you could say, like, what does it mean from the platform vendor perspective, the ecosystem, so the partners that actually build extensions or bots or whatever, and then the developer using our platform. So if you take AI-assisted development as an example, as a platform vendor, we need to be smart about data cleaning, data analytics, and then modeling the machine learning, the deep learning models to actually analyze all that data with the right training sets. And we want to have live learning that we can tailor the suggestions really personally to the user or company based. From an ecosystem perspective, we want our partners to build those bots as well. So we have a pair programming bot and a performance bot, but you can imagine many other things for security, design, whatever. And partners could build these type of bots if we provide them with the right bot framework. But we need to think about data security, privacy, and compliance then, and the performance and scalability of processing all that data, and then actually having then suggestions integrated into our platform in a fast way. And then for a developer, they need in-context assistance. So what kind of context do we actually need to feed to those bots? How can we learn from their behavior? We need to do natural language processing if we want to make the interaction with those bots more natural. So these are just some thoughts if you think about the area of AI-assisted development, and you can do the same thing for these other 3 topics as well. Let's not go through that now, but just as a way to help you think about the type of research that we could use to push ourselves to the next era of low-code platforms. So wrapping up, the dream of this cartoon is still alive, and there's much more we can do. I mean, this is still a dream we can and should all have, I think. But we also need to think beyond just making the existing software engineering approach faster. It's not about looking, okay, what do we currently have? How do we automate things? I think we can also think out of the box and do much more. If you look at those 3D printed houses, it's not just the same house, but then 3D printed. They are actually 3 times stronger because they use new ways of constructing these houses, because you have new opportunities with a 3D printer versus having to do it manually. And I think the same applies to model-driven engineering, to low-code platforms. If you think in a new way about all the opportunities we have, we can do so much more. We have a new context that has been created by low-code platforms. And let's use that context to really improve how enterprises automate and digitize their business. Thank you.
Thank you very much. Thank you. A big applause.
Thank you.
So yeah, let's start with this Q&A session. Thanks for the talk. It's very interesting. So I also have so many questions, but unfortunately I cannot do all of them now. So I don't know if there is some questions from the audience. So I see one from Claudio Di Silvio that say, okay, do you think that reinforcement learning makes sense in the picture of AI-assisted platform? For instance, maybe we can use it together with user feedback. So essentially the question, I think, that is asking if in this idea of having these AI-powered environments, if reinforcement learning can play some role.
Yeah, I think so, but I think it differs over these different areas. So if you think about suggesting a next step in a flow versus analyzing a model to do performance suggestions, it's already a different model you need and a different type of. When we talk about machine learning to do that, but machine learning is multifaceted. So there's many different things that we should use, and I think that's the type of research we are actually looking forward to. How can we make sure we use the right technologies, the right languages or types of machine learning to help us do that? And that can be indeed reinforcement learning or other machine learning models that we can apply there.
Okay, thanks. So yeah, there are so many questions. So let me do in the first in, first out. So I'm afraid I still don't know what low-code is. This is Ulrich that is asking, Ulrich Frank that is asking this. And if you want to promote productivity and flexibility, abstraction is of pivotal relevance. What are the abstraction concepts, characteristics for low-code different from those that have been known for long?
Yeah, I think I hinted at that as well already. Like, I don't think there is a difference, to be honest. Low code is basically, in my mind, model-driven engineering, but applied to enterprise software development and evolved in such a way that enterprises and businesses want to pay money for it and actually see the productivity gains. But the core of a low-code platform is model-driven engineering. That's what it comes from, and I think where the value is. And we just apply that to other areas. And if you look at the history of how we evolved as a company, we solved, that's a big word, but at least we solved in a certain way development. But then we bumped into the next challenge that we could develop an application for a company in 6 weeks. But then it took us 3 months to actually deploy that software in production because we had to talk with IT and get a server and everything. So that's why we started to focus on the cloud part as well. And now basically my request of today is to all those adjacent areas that we used to make it work for enterprises, they can also benefit from more MDE concepts as well to drive that underlying infrastructure in a metadata driven way or things like that.
Yeah, and then I mean, I think that we are prepared the ground for the next question. There is a basic question from the audience. Let's say, is there some requirements that a platform should fulfill for being called a low-code platform?
Yeah, I think everybody has a different opinion about that. But if you look at, I think the only way to define that in a way that is somewhat useful is look at what Forrester and Gartner use as criteria to be included in their low-code analysis, the low-code quadrants, or a wave as it's called by Forrester. And then it's a very broad spectrum of requirements. And what I said before, most of those requirements are not talking about MDE. They talk about all the capabilities you need to actually be able to sell an application development platform into an enterprise. So that's around security, compliance, performance, scalability, data integration possibilities, all those kind of things. But I think, yeah,
okay,
do not have it just no definition. I would stick with those capabilities, although there's a lot of discussion about them as well.
Thanks. So, I mean, I think that we are running out of time, but I would like to at least other two questions. So one is from Michel Chaudron, he's saying Mendix started in automation in business processes. Siemens is also making embedded systems. Are you applying Mendix toolset to embedded systems also, and are there significant differences?
Yeah, that's an interesting question, because actually it's great to see. We're now part of Siemens, so we talk a lot more with the industrial engineers, basically, and they actually are very open to models, because they have been using models for all of their life, so to speak, and they are a lot more open to models than software engineers, because they are like, I don't want to use models. I'm a programming expert. Don't talk to me about models. While those engineers in other disciplines, they actually want to use models, and that's what we are doing within and with the customers of Siemens as well. We are not embedded systems for Mendix. That's a bit too low level to generate from our type of models, but we are with Siemens starting to run Mendix applications on the edge, so on a machine in a factory. And those machines become more powerful every year as well. So you can actually run a full Mendix application on that. They just have Kubernetes on the edge. We run Mendix on that, and you can analyze all the data coming from the machine and then send it to the cloud and so on. So not embedded systems, but we do edge.
Thanks. Then, yeah, last question. And then, I mean, please, there are other questions. It would be great if you could have a look at the remaining questions and answer them. The last question that I would like to do now is the one from Gabriele Tenzer. She's asking, is there any initiative among the low-code platform developers to collaborate on common platform components?
No, not that I know of yet. So I think if I don't know it yet, then I'm kind of sure that it doesn't happen yet, because it would be starting, I think, from the leaders in this category. We did a first attempt to that. Well, so a couple of years ago, we opened our meta model, basically. We said, like, here's our meta model and an SDK to program against it. But of course, the competition, the market is still growing very fast. So the competition is very hot, so to speak. So we are all fighting for our own market position now. I think when the consolidation starts a bit more in the next years, there is definitely a place to start looking at, okay, how do we create interoperability across low-code platforms? How do we connect things in a certain way? Also from a, but I think that will start by customers, large customers, asking for that or demanding it. Before that, I don't see a lot of energy going there. Okay, so thanks a lot. As I said, if you can have a look at the other questions on the chat, this would be great. But then, yeah, unfortunately, we have a long program and we need to shift and move to the next speaker. So, but before doing that, I really would like to thank you again for joining us and for having accepted to be our keynote speaker. Thanks again. Yeah, thanks. And yeah, you can reach me at Twitter or just my full name with dots@mendix.com. And then I can answer more questions, or if you have ideas to collaborate on research, I'm happy to have that conversation. Yes. I'm on holiday this week, actually, so I will answer next week. But I didn't want to miss this workshop, the first workshop on low-code. So thanks for inviting me. Thanks a lot. So then, okay, let's move next. And yeah, let's start with the first section. The first section after the keynote. So we did the model-driven engineering and low-code platform session, and the speaker is Jordi Cabot, that is going to again to present now his opinion on positioning the low-code movement with the field of model-driven engineering. So Jordi, the stage is yours.
Okay. Well, thank you. I think, in fact, that I don't need to do the talk at all. I think that Johan already was very clear on what's the relationship between the two. But let me just at least give my perspective. Okay. So I'm assuming that you see the presentation. I'm in Wova, so it's a little bit confusing to me. Davide, can you confirm?
Yes. Yeah.
Okay. Perfect. So again, the goal is basically to discuss about the relationship between these two concepts, just because, I mean, I think that there's a lot of confusion. And I think that Johan did a great job today on clarifying a little bit the relationship. And I just want to emphasize on that. Because I think it's good for the community that we understand each other and we know what we are talking about, and especially we avoid duplicating effort and wasting time, which I think is what's in danger of happening right now. But just to be clear, this talk is not about fighting with each other. So as you will see, I'm not at all against low code. It's more about trying to answer these research questions, right? So, okay. So when this low code trend started, and I was seeing this just as a kind of from a marketing perspective, but then it turned out that from the research community, there were starting to be some initiative around low code. So I thought that it was maybe the time to think about at least these 3 points. The first one is if there anything fundamentally new behind the low-code movement from a scientific perspective, and then how the low-code concept relates to all this MDD star, so MDE, MDD, MDA, MBE. We already have a lot of acronyms, so how low-code relates to them, and how we can benefit, or what are the implications of low-code for us in the research community. So a very short perspective, because again, Johan already covered some of this. So the definition of low code from the Forrester report is this one. So basically, try to accelerate app delivery. Okay. This was from 2014, emphasizing the role of visual models. But we know in our community that this is not exactly new, right? So Stephen Mellor, one of the fathers of the executable UML, already say they were talking about modeling being commonplace in 3 years' time. But this 3 years' time is not 2023, but it was supposed to be 1988, right? But this trend was already there, even if at the time, and that's one of the big difference, the company were not really paying too much attention to this. These are sentences from a conference, a case conference from 1991. And as you can see, they will use a slightly different vocabulary, but the goal is exactly the same, to emphasize that the system could be somehow generated from the models. So again, 30 years ago, we were already talking about the same concept that now low code is promoting once again. And even Grady Book, which is always saying that the entire history of software engineering is raising the levels of abstraction. And this is what we have been doing in models and the UML communities for the last more than 30 years. So clearly, the concept of low code is not new. So let's see how it relates to the other concept that we may be more familiar with. The first problem we have is that there's no formal definition. So even in Johan's talk, the definition of low code was provided by one single person working for a consulting company, and then was more or less adopted from there. So there's not really been ever a scientific effort to precise the definition of low code, again, with precise terminology, taxonomy of concepts, and so on and so on. I could say that basically the same problem we have with model-driven engineering. So we use MD, MDA, MDD, and we have never really created a precise and clear taxonomy of concepts. So my attempt is this one, that again, it's not new. I wrote this post quite a few years ago, but I think it still applies. So on top, we have model-based engineering, which is basically using models as part of the software engineering process, not as the key element, maybe not as a driver of the process, but as part of it. Then model-driven engineering is basically same concept, using models everywhere, but this time the models are not just decorations or sketches, are really key artifacts that drive the development process or the reverse engineering process or the deployment process, all the aspects of software engineering. Then we have MDD, which to me is basically MDE, but more focused on the development part. So here is where we would find more the traditional code generation approaches and so on. And MDA is just a version of MDD using the OMG terminology, and that at some point was popular. Now it's kind of forgotten, but it's nothing more than MDD, again, using OMG terms. So what is low code in here? Well, I would say it's To me, it's a kind of MDD. At least it's how it's marketed right now, in the sense of it's more about rapid application delivery. I think we could say that low code, as again Johan already said, it's more of a encompasses, includes a platform perspective. So somehow it's not just about generating or interpreting the models, but also about the life cycle. So you could see this also kind of being a mix between MDE and MDD. But again, it's the idea that models are a key part of the software engineering process. So based on this, my first kind of clear message that I would like to share with you today is that, to me, low code is a style of MDD or a style of MDE, if you want. But just that. So it's not something different. It's not a different branch, a different family. It's not a distant cousin of in another software engineering family. Is really a member of our community. That maybe we could say that it's a style of MDD that is focused on specific types of applications. So probably not real-time embedded systems. Instead, it's typically applied to data-driven, web-based enterprise applications. And there's another kind of key characteristic, and it's that when we talk about MDD, we typically include the definition of the language itself as part of the project. So we could go to domain, understand the domain, create a DSL for that domain, and then the code generator, and then have the full toolkit to create and to develop application for the domain. In low code, typically the language itself is provided by the tool vendor and is fixed. So you have to adapt to the language, and therefore part of the work you have to do when selecting a low-code tool is to make sure that the tool or the vendor behind the tool provides a language that is good for the needs that you have. I will not talk too much about no code. I think that here we all agree that no code is more about configuring, plugging, templating, and so on. And to me, it's clear that no code is not just extreme version of low code, as is often assumed by not by us, but I mean, when you look when you read the blog posts or you look at Twitter, many people just use low code / no code, and I think that that's a clear mistake, because I think that we all agree that there's so much you can model, or there's a trade-off between how fine-grained, how refined are the models and the benefit they bring. So at some point, I think we all accept that we may need to add some code, or at least some very low-level models in our process. So this no-code movement is to me is it's a different approach, where basically the only thing you do is to adapt pre-configured components to basically create an application which is just a derivation of an existing one for your specific needs. But it's not really not code would be indeed kind of a different beast if you put it like that. So if low code is a style of MDD, as I say, then I think that still is, of course, it's worth studying low code or the low code movement from many perspectives. I mean, clearly from a social, economical, and marketing perspective, it's really interesting to study why low code has become popular, where MDE or MDD or even UML at the time was not really achieving this kind of success. So from that perspective, it's really worth studying the low code movement. But again, I want to emphasize that I don't see a scientifically new challenge here, meaning that all the scientific challenge that even those that Johan showed us at the end, they are not low code specific. They are, if you want, model driven challenges. So again, I think what I want to avoid at all costs is that I don't want us as a community to create a research bubble where basically we repeat, or we start seeing the same paper that we published at Models or CAIS or ER conferences a few years ago, just by replacing the concept model driven by low code. And I think that there's a risk that this could happen, especially looking at probably younger researchers that may not have this perspective. We have seen this in many different domains. I have a very good colleague of mine that were doing research on distributed and parallel architectures. And in that domain, for a few years, they publish papers on cluster computing. Then they publish the same papers about grid computing, and then they repeated the third time the same papers, but now talking about cloud computing, right? So I think that low code is interesting to study from, again, from the social perspective. That low code, since it's actually used in practice massively, as we have seen, in fact, can provide a lot of inputs and additional challenges to the modeling community based on this practical perspective. So I think that, yes, let's do research on low code, but this research on low code is research on model driven, maybe applied to this specific style, right? But it's not something different. It's not, there's no need to reinvent the wheel. If there's a paper or a solution on solving the same problem from a modeling perspective, it works anyway for the local perspective, right? So, and I think that we have, in fact, plenty of research challenges in the model engineering. So I think that there's plenty of topics that, again, we could see how they fit this specific application scenario of low code. But let's not be confused and assume that there's kind of a new branch of potential research opportunities, just looking at or reinventing or reimagining modeling challenges from a local perspective. As I said before, this is not a fight. In the end, I'm very, very happy to see the success of low code, and to see how low code is trending more and more, and that right now is already being much more popular from a relative perspective. Is more popular than model driven, and I think that we can learn plenty of things about this trendiness of low code. I think that low code did some things very, very good. So I think that the message of low code is very clear. I mean, everyone understands that low code is basically less coding, right? So low code, I had code. So from a, say, developer perspective, I still have code, even if it's interpreted. But let's just simplify, assume that it's kind of generated code. It's just that I need to write less code than before because some of this code is interpreted or generated. Instead, trying to explain model-driven development is much more confusing. It's really much more difficult to convey the message of what's behind MDD. Instead, low code is, it's self-explanatory. It also sounds familiar. So the marketing message here is still focused on the code aspect. So to a developer, it's not like telling him that he need to completely change and relearn how software is developed. It's kind of, again, it's still coding, but it's slightly different alternative approach to code, where you maybe you withdraw part of your code and then you will program the rest. So it's much more familiar. I also think that we need to learn about the benefits of having a simpler pipeline. So typically, when you take a low-code tool, you model the system, then you click a button, you get a URL with the system deployed already in the cloud. Instead, in the MDE, the classical MDE approach, we often end up having a very long set of transformation chains because we're very purist and we want to make sure that each level of modeling has a different abstraction level. So we go from high abstraction level to lower abstraction level with a model transformation, then another one, and then another one. And at some point at the end, maybe after 5 steps, we have this model to text transformation that will generate the code. So I think that, of course, from a conceptual perspective, having these long chains maybe conceptually the best, or the strictly speaking the purest approach. But clearly, if you can simplify the life of the user by just having a one-click deployment button, that's something that will massively increase the usage of your tool, of your approach. And of course, low-code tools are better. I don't know how many of you have used Mendix or OutSystems or any of the other low-code vendors, but those are real tools. With all respect to EMF and Eclipse, it's not exactly the same to try to teach model engineering to students by first installing Eclipse, installing EMF, installing an editor, how installing all the plugins and dependencies, than taking Mendix, OutSystems again, or one of the major low-code providers, and use that. So I think that on that, it's also a lesson on how the usability of the tools is key if we want to have an impact on the society. Also because there have already been several studies that says that the success of an MDD project in a company depends not so much about the technical aspects, so not so much about the quality of the language, but on the social and managerial aspects behind the project, right? So I think that here there's plenty of lessons learned for us, without wanting to give the idea to the user that development is easy. So I think one thing, it doesn't go against the other one. But I think there's plenty of messages that we should really try to integrate in any kind of modeling research. So to me, and that's the second key message. So the first one was that there's no scientific difference, but the second one is that, in fact, that's not bad. In fact, it's good, because for me, low code is a huge opportunity to bring modeling and our modeling expertise to new domains, to new markets, and to new communities that so far we have been unable to reach, partially because of the problem that I was mentioning in the slide before. And of course, once we hook them up to modeling, we somehow get them into the community. It would be much more easier to just bring alternative modeling techniques, more complex modeling tools that maybe are better suited for the kind of problem that they have. So I think low code is a huge opportunity for us and something we should really try to benefit from. So again, I think that that's really a love story between the low code and us, and we just need to make sure that we complement each other. We understand that are kind of just brothers and sisters, and that the best thing we could do is to learn low code. That research agenda that Johan showed, probably some of those items were already or are already partially solved in the model-driven community, so they can learn from us. But of course, we can also learn from them. And we have to be careful in the sense that to be careful that while we just talk to each other, we don't see no-code approaches advancing us. I think that's a danger, because again, I don't think that what you can do with no-code is comparable to what we can do. But I do start seeing a lot of people that, of course, they go to the extreme of just getting no-code solutions to develop their tools, instead of understanding the complexities of software development. And of course, once something gets popular, there's already people inventing the next big thing, because of course marketing never stops, and we need to keep selling tools, we need to keep selling reports, and we need to keep getting PhDs, right? So I start to see that in the later report, there's this new concept of multi-experience development, which is basically emphasizing the need of having user interface that combine different types of interactions, classical graphic interface, but also bots, chat bots, voice bots. So I think that now that we have agreed that low-code and modern engineering is basically the same, we may start also applying all our modeling expertise to these new kind of software applications where they combine these different types of user interface at the same time. Thank you, and as you can see, I'm ready for your questions.
Thanks, Jordi. Thanks for sharing with us what's your opinion on this field. And I take let's see, we are running out of time. I take a couple of questions. So the one is from Stoyan Garbatov, and say, low code is a style of MDD. What is your take on low code having more of a full vertical position? For example, going beyond the development to also cover design and the DevOps and lifecycle management.
Well, I mean, yeah, I've seen that. I mentioned that. But this is also something that MD is already doing. So there was a MD Intelligence workshop on Friday. So MD and artificial intelligence, how we use AI to better modeling is part of our community. I think not this year, but last year there was DevOps and modeling. So I think that all these aspects of platform or full lifecycle support are also a concern for us. As something that the modeling engineering community is already studying as well.
Thanks. And now the question of the question. is from Bernard. Would low code be a good opportunity for us and the vendors to come up with better tools?
Definitely. That's why I was saying, right? So I think that we can complement each other. So low code is basically the most successful story we have, in the sense of, at least in terms of probably number of users, range of companies. So for sure we can get the requirements that we typically don't have from real users, from them, and we can then see, okay, if they have this research agenda. Probably we have already investigated some of those details before. Maybe now it's the time to recover them and try to apply them, now that we have a tool and a community of people using modeling, even if they don't call it like that.
Yeah, last question, because otherwise we are already on late. So the last question is, how do you see the low-code state of the art today as contrasted with the efforts of the past, such as the embodied in tools, such as the effort embodied in tools in the 19th, such as LabVIEW, for example?
Well, I think that technology has helped a lot. So this idea of drawing a model, clicking on a button and getting the model deployed. So the system, you see the system already deployed in a URL that you can access and start using, is something that is attracting, is very attractive for a lot of people. And that's the possibility of having this automatic deployment on the cloud is not something which is low code specific. It's just a matter of the technology you have today available. I remember 20 years ago, there was already a company in Spain that was offering, or was trying to offer this kind of service. But basically, you would be sending them by mail the models, and then after a few days, they would get back to you with the tool, the system deployed in their cloud, in their private cloud. But it was not an agile process. It was not something you could do iteratively. The technology you have today has really made possible some of these dreams that we already had from forever. So I think that the low-code platforms are doing a very good job in making sure that the tools are really usable and are really powerful, so that modeling is not a problem anymore. Is already seen as an enabler, because all the rest is working perfectly.
Yeah. Okay. Last question. Hi, Jordi. You mentioned the distinction between low-code modeling and no-code configuration. In your opinion, at what point does low-code have too little code to be useful and is more a fancy code, fancy no-code version? In other words, how much should we remove?
Well, I think that more than the quantity is the possibility of actually writing the code. So no code, really, you are not supposed to code anything, and probably you cannot even do it, even if you wanted, right? So instead of in low code, there's always this option of having a black box somewhere where you can plug, or you can copy paste your Java or whatever language code to implement a complex function. So I think it's not so much about the quantity, it's about the possibility of not having to model everything, because that's really impossible. So if you don't allow any kind of programming, then you end up having solutions that are only allowing you to create simple applications that, again, are this more configuration or plugging.
Okay, I would close here. Thanks, Jordi, because I think that we are running out of time. So thanks a lot for your talk. And I think that now we have a virtual break. And the last talk, I suggest to shift the last talk of this section to the next one. Yeah, and then see you in the other room. So now we have to go back to UVA and select the link, of the second session. And enjoy your coffee, and see you at 3 sharp.